Alright, welcome to page 3 of the notes, and now we're going to talk about notations of partial derivatives. So, say if we have our function z is defined by f of xy, we can write f sub x of xy is the partial derivative with respect to x. So these are multiple ways that we can write our actual derivative. And these two notations are going to be the notations that we're going to use the most, which is just going to have function sub x as the partial derivative with respect to x, or at the top you see this symbol, and it's kind of like making a 2 but not like finishing the 2 when you're writing it. So like partial, that would be considered partial. So that means partial of f over partial x means taking the partial derivative of our function with respect to x. Alright, and again, we can also say partial of z because we can also define that by z as well. And so these are just the different notations that we can use to say, hey, we're taking the partial derivative. So a lot of times when you will see this, right, it means that we took the partial derivative, right? And these are the most common notations that we have for taking the partial derivative. You'll see this one quite often as well. So rules for finding partial derivatives of z is equal to f of xy. To find f sub x, regard y as a constant and differentiate the function with respect to x. And then the same thing with y. You're going to find that this is not going to be very difficult to actually do. And so that's what we're going to do. We're just going to take derivatives and we're going to treat whatever variable that we're not taking the derivative of, we're just treating that as it's going to be a constant. So let's go ahead and do example 18. So find the first partial derivative of the function. And so we're going to find the first partial derivatives. And so we're going to do f of x first, f sub x, and then we'll do f sub y. So f sub x. So we're going to take the derivative with respect to x. So we have x, the square root of x, natural log of t. What we can do is say x to the 1/2. So then we can just bring down the 1/2 x to the negative 1/2. And natural log of t, we're just going to keep that as a constant. And so what we really have is natural log of t over 2 square roots of x. Alright, now let's find the partial derivative with respect to y. So again, we can use either notation. Again, I'm just going to stay with f sub y. And or in this case, f sub t, because t is our other variable. So f sub t. And derivative of natural log of t is just going to be 1 over t. So we have the square root of x times 1 over t, which just gives us the square root of x over t. All right, and we've taken both derivatives. Both partial derivatives, I'm sorry. All right, next one, find the first partial derivatives of the function. And so here we have the function w. And so here I'm just going to use the other notation. Instead of saying w sub v and w sub u, I'm just going to go ahead and say, and change the color there, separate the partial of our function with respect to, let's do v first. And so here we have a quotient rule because we have v in the numerator and the denominator. So I have e to the v. The derivative of e to the v is just e to the v times the bottom, u plus v squared, minus quotient rule. The derivative of the bottom, which is going to be u plus v squared, is just 2v, e to the v, times the first, all over u plus v squared. And then we could pull an e to the v out if we wanted to, or we could just leave it there, and I'm just going to leave it there. We don't have to simplify that. All right, let's do the next one. So let's do the partial of w with respect to u this time. All right, because I have e to the v divided by u plus v squared, I can do the quotient rule again. Or if you want to, I just want to show you, both ways. Let me change just the color so that you can see me rewriting this. E to the v times u plus v squared to the negative 1. If you wanted to work on it this way, you can as well. Multiply, so we get negative e to the v times u plus v squared to the negative 2 times the derivative of u, which is just 1, so we get negative e to the v over u plus v squared. All right. Interpretations of partial derivatives.